Hello, and welcome to Rural Delivery. This week, we hear about a fascinating mutation in sheep that produces a lustrous, self-felting fibre that may hold the clue to the genetic factors that govern the structure of wool. We visit a world-renowned sheep station turned conservation classroom, the Guthrie-Smith Arboretum in Hawke's Bay. And we find out about what's been described as a magic plant, a giant grass with multiple uses called miscanthus. In a bid to increase the value of wool and in turn the profitability of sheep farming, Ag Research has a program underway looking at the genetic factors that govern the structure of wool fibre. The hope is that, with the knowledge gained, sheep will be able to be bred with designer wool types for specific end users. Dr. David Scobie explains.
The luster mutants have been around for a long, long time. We find scientific reports back to the 1940s about them, but we've never really got to the bottom of what causes that actual change in the wool. And it's a single gene, and we still haven't discovered it. The sheep with this mutation have a very shiny fleece, particularly when they're first born, and it completely lacks crimp compared to the other sheep of the same breed that they come from. Strangely, a lot of them don't have the incisors when they're born. Some of them do, and some of them develop them later in life. They also have difficulties with their lungs, a lot of them. So during embryology, the development of the skin and the development of the internal surfaces, like the gut lining and the lung lining, develop from the same sort of tissues. And so there may be some really deep development there, which is causing that screw up in the external surfaces. If we could find that one gene that causes that mutation and changes all of those things so dramatically, then we'll know where it lies, and we'll be able to find the other genes that give us good wool quality and perhaps some of those other tooth eruption and those sorts of things. We've done a lot of the physical measurements, and the other crew that I've been working with have done some of the proteins and done some of the scanning and electron microscopy, but we haven't yet done the gene test.
That's Sharon.
Sharon was born in October in the middle of the night. She was really shiny, and we were excited to find Sharon because it was the first one that we'd been able to produce on the research farm. Her mother was a felting luster mutant, and she showed up. And it's just amazing when you see them. They're just so outstanding. Yeah, you can still see the luster creeping through even in today's conditions. Compared to this. So Sharon has a slight respiratory disorder. We did have some others which we think actually died from pneumonia or something like that because of these issues with their lungs. But if Sharon goes for a short run or follows you around the paddock, she will start breathing heavily. And on a hot day for a sheep, but on a warm day for us, she'll be breathing quite heavily. We're about 5 years of messing around with these sheep. We put the advert out to get hold of some a bit before that, and we've had a good response and good help from the rural community to pick up some of those animals. What we got hold of on Friday was a ram lamb. When you get a ram, you can produce a whole lot of progeny very fast, and you can get normal and abnormal side by side and use those. For the first 4 years of the trial, we hadn't been able to find a ram.
What happens is that when you get a mutation, you get a radical change in the structure of the fibre, and you get also quite a radical change in the proteins that are present as well. So by looking at mutants in normal sheep, we'll get an idea of which protein is important and how they help develop the fibre as it grows. Ultimately, I think we'd like to have some markers we can say to farmers that if you particularly focus on these animals, we develop a gene test, for example, we could say, well, these ones favour this particular trait, and if we can develop that trait further, then it can help refine their breeding program. There's about 12 proteins that are affected by this. We have got the skills within ag research, and we have a good genetic knowledge of the genome now, so it's just a question of actually finding the right animals. At the moment, we're still trying to establish the connection between the proteins and the fibre structure. But what we wanted to do the next stage is to start doing gene tests and start looking for the actual cause of the mutation. So this is a scanning electron microscope image of normal fibres and mutant fibres. And the thing to note is in the normal fibres you get these kinks and flat regions in the fibre, whereas in the mutant fibre you get straight cylindrical fibres.
So we've got this sample here, which is a lamb shearing sample from a luster mutant. It was that little ram lamb. The next sample that we've got is from an older animal. And you can see just even from this very small sample, it's quite matted and cotted and it tangles up. And then just for comparison, we've got a normal wool sample. Look, some samples have more crimp, some have more length, some have less crimp, but I think you'll see the difference between these two samples and that is quite dramatic. We've found the luster mutant genes in Suffolk, Merino, Perendale, Romney and composite sheep so far. Every now and then we'd come across a sheep like this one that we think, at the start of its life, it's a mutant. Then all of a sudden at lamb shearing time, it's turned into a normal Perendale in terms of its fleece. If you shear that animal, we came back the next year, only way we could identify it was from its ear tag number. So this particular mutation giving us lustrous fibres, we could use it in something like this. So this is actually made out of mohair. This is a goat fibre, but it has the same appearance. Some people might be aware of the Stansborough fibres, and they're making products like the elvish cloth that was used in the Lord of the Rings out of lustrous fibres. So you can use it for that. I'm not saying that everybody in the world is going to be using a granny's lap rug, but yeah, there's certain things you could use it for if you wanted to breed sheep like this.
We're back soon in Hawke's Bay at an arboretum, the legacy of sheep farmer and naturalist Herbert Guthrie-Smith. 90 hectares of what was the world-famous sheep station of Herbert Guthrie-Smith Tutira is now an ecologically important haven for native birds and insects and rare and endangered native and exotic trees. The property is administered by a trust and managed by a curator. Its current role is that of an outdoor education centre, where mainly primary and intermediate school children are introduced to environmental issues and the importance of biodiversity.
The property was originally owned by Herbert Guthrie-Smith, and he had about 20,000 acres to start with, and he leased further land. At its maximum, he was farming 64,000 acres, and he was fascinated by the life that was around him and its the effect of man on the land and the landscape. He wrote a world-famous book, Tutira, The History of a New Zealand Sheep Station, which is recognised worldwide as a wonderful naturalist volume and has been used as textbooks around the world. Guthrie-Smith himself recognised that we probably shouldn't be farming some of this land. He's fascinated with bird life, everything around him, and he documented it in every detail and was very concerned with the effects of the pioneers, really, and what was introduced to New Zealand, and that's his legacy.
I like to call myself the plantsman because I basically have everything to do with the plants, how they're grown, how they get here, what we plant, and their future development and the planning of the arboretum. At the moment we're standing at the edge of the jungle, which is my nursery. This is one of our rarer trees. This I saw in a catalogue as seedlings, so I bought 50 of them, knowing that I'd probably never ever see this for sale again. It's called a pseudo-larix, which means a false larch, and this one comes from China. And this has a beautiful pale green foliage, fantastic in the autumn. So we've got a nice little block of these. This is one of the main parts of the arboretum, where we've got many separate sections devoted to particular countries. We're now standing in the Chinese section. On the opposite side, we've got the Mediterranean section. And in there, we've got a lot of the interesting fruit trees and nut trees, such as walnuts and damsons and plums and prunes and hazelnuts and all sorts of things. So that's quite an interesting food stock for the kids when they're traipsing through. One of the things that we're developing as a special interest here are trees that are particularly attractive to honeybees. We've got an example of a prune tree, which is called Stanley Plum. And this is a very good tree for a home gardener or a farmer or anybody because it's self-fertile. So you're guaranteed a crop every year. The quince is an ornamental. It's got hidden vices which are very big thorns, and it makes a very good protective hedge. It's a good tough tree. Most of our trees are labelled either as an individual tree or as a group of trees. It has a number, and that is part of our GPS recording system, which indicates where all our trees are.
The Arboretum's all about establishing or developing something that's very special for people to come and visit and enjoy. The Education Centre, it's providing opportunities for kids to get out of town and come and experience things up here, like our activities like our high ropes, our canoeing, our educational programs, and lots of other things that we have on site. A big focus for us is environmental education here at Guthrie-Smith. So we run a number of programs. Our first one that we established is based around the Arboretum. Another program that we run is our conservation program. It's based around Conservation Week, and that's sponsored by the Hawke's Bay Regional Council and PAMPAC, our local pulp and paper mill. We're just in the process of rolling out a new program on water education. So looking at the lakes of Tutira and how farming, how climate change and everything else, the removal of trees over 100, 200 years has affected our lakes. We'd have well over 1,000 children come through the property annually, and our focus is probably more with primary and intermediate age kids, but we do have high schools come here on leadership camps as well. The place is open to the public on Sundays. There's no charge of coming and walking around here, so it's all part of opening the property up to people to come and enjoy. Behind the homestead is a block called the Hangar. Guthrie-Smith shut that area up in the late 1890s. It's a steep face. A hangar is a Scottish term for a slope between two flat areas, so he shut that up in the late 1890s and observed what was growing back there over 50 or 60 years, right up until his death in 1940. Because of the special nature of the hangar, more recently we placed it under Kiwi 2 covenant, so it's now protected. We're looking at developing a visitor centre with a cafeteria, possibly with a nursery, which would be on the side for people to be able to come and buy trees. So we're sort of 15 years into a project which might take up to 40, 50 years to establish. So it takes a long time to grow a tree. It's going to take us a long time to get this place fully established. So we're big plans for the future.
When we return, we find out about the many uses of miscanthus grass. Miscanthus grass is a giant grass originating in Japan. Similar to sugarcane, it grows from a rhizome but doesn't spread like bamboo. Ecology professor Steve Ratton has been working in a number of research projects involving the plant. He believes it shows great promise for a variety of primary industry applications.
We think this grass is a magic grass, actually. If we made a list, it would be something like shelter for livestock, biomass for burning in a burner, a carbohydrate fuel to make diesel with, We get more earthworms up to 100 metres downwind from it because the soil remains moister longer. And we get 18% more grass growth up to 100 metres downwind. There's a company in the USA, in Tennessee, that takes grasses like this and turns them into liquid biofuel. My dream is that farmers would grow miscanthus on their own surrounding farms, put it through this magic machine. What's called renewable diesel would come out the other end, and it can be used immediately in an engine. And the amazing thing is, it's very low in sulfur, and its cetane level, which is like octane in petrol, is higher than the cetane level of mineral diesel. This thing grows so fast that we reckon that per year we could harvest between 30 and 40 tonnes of dry matter, largely cellulose, every year, because there's a dirty great rhizome under the ground. So that's a massive amount of carbon, more than a poplar tree would produce in 1 year, certainly. And that massive amount of carbon can be used to make liquid fuels, of course. Dairy waste can be put on top of this grass, and virtually nothing goes down underground. It traps it physically, such as the organic matter, and the plant is so fast growing it takes it up from its roots. We're using it as mulches under the trees. And what does that do? No weed killers needed, more soil water, and actually more earthworms, and more fungi, which are beneficial fungi in the soil. So all these advantages of a healthy soil, which many farmers know about, can be enhanced with chopped up miscanthus under the trees, and it lasts for years without needing to be topped up. Some sheep milk companies are using it now as bedding for the milking ewes, and that's happening a lot in the UK as well. We normally like to plant in September, which is springtime, and the plant would be a metre high in the first year. And ultimately, maybe 3 years, especially when it's irrigated on a dairy farm, 4 metres in 3 years. And that's when you get the kick-in of 30 tonnes per hectare. Behind us here is a 7 metre wide strip, and that's ideal for using a maize chopper, so they can chop it up into pieces. They can stay on farm as a mulch, they can make them into pellets, they can burn them. All options open up at that point. The rhizome itself can be like 2 footballs in size, but we can take all these shoots off it, and each one of these pieces has lots of little buds on it, and each of these buds will be a new miscanthus plant. If you're using them for mulch, there are various options. I would use a coarser mulch like this one, which is a bit more dense and would not blow away so easily. If you're talking about fuel for a milk factory or something like that, you can co-fire that factory boiler with a mixture of the coal, which they're using now, let's say, and these pellets, which are crushed up miscanthus again. And these are really clever because there's no resin or glue in there, it's just pressure that puts them together. So you could burn that on its own, or you could mix it with coal that's already in use and co-fire it down the belt. These are also miscanthus, so you may not believe it, and it's crushed up and with a bit of resin, I think, and turned into these pellets, and therefore domestic home heating.
In addition to the other benefits of miscanthus that have been talked about, we found that miscanthus hosted quite a few different types of animals. Most notably was the endemic skinks. It was really good to see that this introduced grass that helps the farm, but actually can be used as an offshoot, as a conservation effort as well. One thing we looked at was whether having bumblebee nests or boxes would be used within miscanthus shelter belts. It was a really good result. We found that miscanthus provides quite a good microclimate or habitat for bumblebee nests. The obvious advantages of having bumblebee nests in, say, a dairy farm is that they can pollinate red clover. It doesn't necessarily have to be on the dairy farm that the nests are located in, but anywhere in the surrounding area. They also help pollinate other crops, sort of a supplement if honeybees aren't around.
Looked like a good thing to try out, yeah, since we have pivot irrigation, and yeah, I thought it might be a good shelter option and things. As far as blocking the wind, it's exceptional. in Canterbury, in particular the northwest, that rips the moisture out of the ground like it's going out of fashion. So, you know, we can lose up to 10 mils a day here in the bad northwest of soil moisture. So anything that can stop that, the cows, if they break into it, will eat it. We'll eat the top, but it's a bit like sort of mazy cuddy grass, so they eat it probably just to annoy you more than anything. But the actual bamboo, yeah, like baled up, I think it'd be far more use as a fuel for a furnace, and you wouldn't have to buy another tomato stake if you grew tomatoes in your life, because they're great tomato stakes. Yeah. It breaks the farm up nicely. Because we have a pivot irrigator also, you don't have any issues with it hooking on the pivot nozzles. These just go straight through it very easily, and so there's no issues there at all. I'm going to probably plant it in front of our house to block the road. It grows so fast. Within 2 years it's at full height, and like a 7 metre belt is more than thick enough so you can't see, or you know, even blocks noise through it. It's quite really good, yeah.
For more information on these and other stories you may have missed, visit our website. You can get there via tvnz.co.nz. You can also watch this program on TVNZ On Demand. Next week, we catch up on the latest research into the effects of mesh on pests and diseases of potato and other crops. We look at work underway to contain and control the spread of catfish throughout Waikato water systems. And we learn about the challenges that exist to increase the numbers of super pollinators known as leaf-cutting bees. We hope you enjoyed the program. Please join us again next time. This program was made with funding from New Zealand On Air.